So when mass can, when you pixie boot those nodes and mass wants to manage them, it starts an image on them and collect information of what is inside the box, inside that server, knowing all the serial numbers, the PCI IDs, the cards, etc., and put that into its own database. So I can go and check what has been found when analyzing, commissioning that node. If it's possible, and if we have the certification for it, and for some servers it's not, it can automatically discover the IPMI, ILO, etc. parameters for you, and put that into the base for you. And if not, some servers disallow that, like the password for ILO. You have to put that into mass yourself. And you do that here, and here you put your power parameter. And then mass will shut down the node, and it will be ready, it will be queued, ready to be consumed. Okay. Once we've done that with mass, we look at it and says, that's a resource manager. What's a cloud? It's a resource manager with an API. Let's put an API on mass. And suddenly we were able, it was 2-3 years ago, to consume hardware resources as efficiently as cloud resources. And instead of reinventing new tools to deploy service because it was on bare metal, we just look at what we've done with Juju on the orchestration and plug Juju to that API. So Juju will consume that API that will give Juju hardware, and then use that and push services like Juju does for clouds and was doing for clouds even longer than that. This allows us to have to deploy OpenStack itself as yet another workload. That's the point of it. What I've done just after installing, connecting to the network, I just bootstrap. So once you declare your environment, okay, I just run that command. This one is interesting. It's I just bootstrap Juju, meaning the environment is setting up the interface. So telling Juju you're going to use that interface. Here is the endpoint, the user, the password, etc. It's simple YAML file with just the information to connect. So it's pretty simple just to set it up, and we make it even simpler with Juju Quick Start. A little helper to help you to set up your environment. Once you've done that, you just have to bootstrap. So Juju will use a resource and put Juju itself somewhere in your environment. Here I use something I call constraint and tags. You remember I show you all the different hardware characteristics that mass discovered. Using the API, I can tell mass to put a tag or to tag resources for me. Meaning I can tell him, I know that is, if you find this part number, I want you to put the tag nuke version 1. And then everyone using the mass API can reuse that tag and says, I want a resource that has that tag attached to it. And you can do that to hundreds or thousands of them. And here in mass, I have also a few VMs to help me doing the setups correctly. And I decided to push Juju on a VM, so I don't consume a node just for that, and put the Juju GUI on top. And Juju GUI is just Juju deploy Juju GUI. In the next version of Juju, the GUI will be embedded with Juju, with the bootstrap, so you don't have to worry about that. Let's go to the GUI. So of course, if you're in IT for more than 6 months, you love CLIs and scripts. Everything is available as CLIs and scripts. And we even have a Juju API. So you can have the best of both worlds. But when it comes to deploy complex services with hundreds of nodes and resources, it becomes more complex to do that. So this morning, Mark drag and drop the bundle, so I will use the script. But that's the exact same file that defines the environment. Sorry about my typing. I usually have another keyboard. I have a French keyboard, so sometimes it goes there. So here I just tell Juju to deploy a complete Icehouse with Ceph, with 3 Nova Compute, 3 safe nodes, Celometer, and connect Glance and Cinder to Ceph, etc. It's quite a complex architecture and setup. So what Juju does is talking to Mass and ask Mass, I need to deploy Nova Compute. Mass, give me a resource. Mass, boot a node. And once the OS is installed on the node, put the key, etc., cloud init style of the tenant in Mass to that node and give access to Juju. Then Juju can install Nova Compute on the node and connect that unit to all the other ones. You probably will be able to see the little lights coming up. Let me see. See if it's a real live demo. Yeah. So every one is one server. So I Juju use and consume a few of those, and is currently installing stuff. And you can see it into the GUI over there.
How many servers does that the OpenStack use here?
Here I use 5 or 6.
5 or 6?
With Juju, you can really choose how you deploy things. So you can deploy on a real server if you use Mass, or on VMs, or on containers.
But now you deploy on real servers.
I deploy on real servers. I collocate some of the services. So I tell this one go with this one on the same servers. Or I could also tell Juju to create a container and put the service in it for me. It's as simple as Juju deploy, like I can do Juju deploy MySQL LXC 2.4, and then Juju will create a container for me and install MySQL in that container on the machine for me. And then I can add a unit to a real server when I scale, and have a complete server when I need more resources.
So do you have a hypervisor installed here with Juju?
Here it's using a combination of real hardware and VMs, but it gets everything from Mass. And we choose to deploy with KVM. So here you see that some of the nodes are allocated and a few nodes are queued. So Juju itself is here, and I have VMs for Neutron, and then Juju use all of those nodes. In the next version of the Juju GUI, you will be able to have a view of the machines that are used and how they are used and what services is where. We are polishing it. I don't have the preview yet on that box, but we are very active on that one. So here I decided to install OpenStack using KVM. So you already see that MySQL, RabbitMQ, and Keystone are up, and waiting the other guys to join the party. Where was? Yes?
You have in the orange box, there are microservers, right? You have 10 servers there?
Yes.
Physical servers.
Yes.
And is there any mapping between those servers? Are you using all of them now?
I'm using using 8 of them, or 7 of them.
Theoretically, could install.
It doesn't matter. The thing is, mass take care of the resources. So it's really the pet and cattle paradigm. You have mass see the servers as a bunch of servers. They're even resources. If you want to tag them as this pool of resources is different than this one, you can. But by default, you don't have to. If you don't have to, you just you ask mass to give you one server, it will find one available and give it to you. And I can have another, it's multi-user. So we can share the same pool of resources of real hardware with 4 or 5 people and deploy and use and share those. And as soon as I'm finished, I release them and mass put them back in the pool and someone else can use it. Exactly like you don't know where the VM is when you ask Amazon or Azure, and you don't care. That the last thing you want is knowing, because you're going to have 10,000 of them.
But you do care. You don't want to have like your controller node, your controller services running on one of the computers. You don't want I don't know, Newton server running.
By default, you do use, if you want to have 2 services on the same machines or on containers, you have to ask for it. By default, Juju would put one service in one unit, okay. in one service. Some of them are collocated here. I collocate compute and Ceph.
And this is part of the settings that you are putting.
I define that in the bundle. So the bundle is a file that defines this, and I can just, from the GUI, export it. Which means I can decide it, maybe it will not appear, whatever. So as you see, it's a very simple YAML file defining where I should find my Ceilometer chomps, which version, etc., how many units I want, how many machines I want to be spin up, which version, because here I choose Icehouse, I can have Havana, Grizzly, others. And this is for the GUI to make things simpler. When you start to have many of them, it's good to be able to tell the GUI where to put things, otherwise you just have something messy all the time. And then you can define some options. I will show you the other one where we define where to put them. But here I decided, for example, where is it? This is the one I deployed, actually. Okay, this is where I define all those things. Here I have something called tags and constraint, and that tag I define it in mass. So in mass, I decided that this specific unit will be Newton because it's connected to the rest of the world, and this one I want that service exactly here for a reason. But the rest, I don't care if my Nova compute is on node 5 or 7. They're equal.
What about the state? Juju can monitor the state of the system, because let's say I'm doing the initial deployment with Juju, and then like a couple of months later I need to change some of the settings, like in Puppet. You just changing the parameter and even pull the change, and we make sure that I'm aligned all across my deployment.
So
is it like for the initial setup?
no, you can continue to use Juju to change your architecture, evolve, scale. Juju will take that role, but it's not the role of monitoring the health of the services itself. But it allows you to really connect to any monitoring system you want.
No, I don't. When I say monitor, I didn't mean like
When
I meant like monitoring the state of the server, the configuration.
the configuration, you know when you run the hooks if the hooks. So did you use charms? So let me show you. What's a charm? Let's take Nova Compute. Let's hit change. Okay, up. So all those, or do you write a charms, or do you define what the Nova Compute service for Juju to be able to use it and consume it? Juju doesn't care what language you prefer. Of course, Nova people prefer Python, so they write the charms in Python. But if you prefer to reuse your Puppet, you can reuse that for the install, start, stop, etc. And have to look at the relationship, because that's quite unique to Juju. Here I have the relationship to RabbitMQ. So every time something changes in the configuration of RabbitMQ or the Nova Computes themselves that can be related to that, Juju will call that hook on both sides, on RabbitMQ and on Nova Compute, and gives you a chance, even on hundreds of machines, to adapt to that change in the configuration. And if that script fails, Juju will show you that the configuration could not be applied, something didn't work. And then you can easily go to that service, to that unit, and debug what's going on. You have, and it's very easy to do it. Let's say I want to check that one, and it's I have a trouble. I have something not working. The only thing I have to do, I will do it as soon as everything will be up. Is Juju debug hooks, Nova Compute unit whatever 5, and I will log into that machines. So I don't have to know that the IP, etc. Juju knows for me. Juju knows which machine everything is on. So I don't have to worry about that. And we'll stop the Juju state machinery. And as soon as you will call a hook, because you change something, or you force it, you can do that too. It will give you another, it will use BioView or Tmux, that's screen, and give you a chance to be able to see what's, manually run the script, see what's going wrong, or to fix it, or to change it. Then you can change your charms and upgrade and push it again in real life. So a very convenient way to move things around, etc. The same goes for logging into the different machines. You just Juju SSH Nova Compute /free, and I will go directly to the third version of Nova Compute, which means I don't really care where it is in the data center. Juju knows for me, and I care about the service. I don't care the IP of the machine. That's pre-cloud. And if you go to thousands of machines, knowing all of them, will just take all your cycles instead of you doing your job of running the service. As it goes for monitoring the whole thing, we can, with Juju, deploy monitoring systems and connect all the service to it. It's what we call a subordinate charms. A subordinate charms will not, let's do it. Let's say I want to monitor this with Nagios. We all love open source, right? And actually, I have a slightly different version of Nagios that I want to test, because I love to modify things. So I copy the branch, I copy the charms locally on the machines, modify the charm scripts to cope with my whatever, things, bugs. There is bugs, always. Things like this. And I decided to push it to that environment. So you will see Nagios a pairing over there. Okay, here is Nagios. So Juju is currently installing 1 unit of Nagios into one server. You probably have another light over there, and continuing to install OpenStack on the rest. And if you look at Nova Compute, I don't have 1, but I have 3 units here, meaning that Juju is installing Nova Compute on 3 different units, servers, machines. Okay? And it's continuing to do that. Of course, we have logs. To see what Juju is actually doing on all those machines. So here I can see I am installing and unpacking stuff on the MongoDB 0 unit. I can have several MongoDB units, and also all the other ones will show up here in the logs. But let's go back to the subordinate charms, and I will get it from the store. I play a bit with the different possibilities just to show them, okay? Tell me if it's a bit too much. So I will deploy the NRPE charm. Okay. The error message is because I clicked twice. I was not patient enough. So this one is not going to build, to consume a unit. This one will stay inside Juju. It's what we call a subordinate. And I will be able to relate it to all the other guys. Meaning I can build a relationship like this. Of course, I can do all that with CLIs. And what that guy is going to do is going to configure NRPE agents on all the units of all those services for you. And then connect to a real Nagios here that I deploy, and being able to monitor your complete environments. And if you start to scale out, you start small and you want more servers, you don't have to tell all those guys anymore. If I add 20 units of Nova Compute to the deployment, because I already set the relationship, Juju will deploy Nova Compute, will connect to RabbitMQ, MySQL, Keystone, all those guys, plus NRPE on that VMs, on those 10, 20 VMs, and NRPE will talk Nagios, hey, I have more units, here they are, boom. And if you don't like Nagios, or if you have an external Nagios, there is another charms where you just configure, hey, Nagios, I already have Nagios, he's here on my network, and this little guy will just push things to your Nagios that you already have. You don't have to install something in Juju to be able to reuse the stuff you already have. But then the stuff you already have can suddenly talk cloud and scale out, thanks to Juju, because Juju will just speaks the language of the other guy, and you can even write your own charms to connect to your proprietary logging system, whatever, and only deploy, use it when you are in production, but still can use an Icehouse or something for testing and developing, etc. But Juju will make the sharing of the architecture between the guys testing, the guys trying things, and the guys really deploying it super easy. It's try and test for architects. That's what it is. The GUI, as you see it, is like a canvas, like a whiteboard. I'm an architect too. The first thing we do when we want to deploy a new workload, we go to a whiteboard and we draw boxes and relay them. And then we decide that one is not good and put another one.
So basically,
exactly this.
That if you do judo, you don't need the puppet.
Correct. You don't need it, but if you love it, you love puppet, you want to you invest a lot in your puppet. I don't know what puppet use, but you keep saying recipe, but that's for chef. In your puppet scripts and stuff like this, you can encapsulate your puppet scripts into a charms. So you can reuse your puppet scripts, put that in a hook, create the relationship, and have a charms there. And suddenly, let's say you love puppet, but this guy loves chef. And if he does the same, the only thing you have to exchange is not learning the new language and the new world of the other guys, is what information I need to exchange. What is, with which URL the service, what's the endpoint, login, password, and stuff, and then you just connect your two services. Suddenly, the puppet guys can talk to the chef guys, and many others. We're going to have Windows charms. You're going to be able to deploy Active Directory with Juju. Let's think about it. Here I have an OpenStack, a full open source environment, and we have Keystone. We have a single sign-on. You will be able to Juju deploy Active Directory and relate to Keystone, and then you can automatically, if you write your script correctly, you can very easily, repeatedly, connect to Active Directory and to an OpenStack environment. So we are very agnostic to that. And the same way I deploy OpenStack here, I can deploy another workload like Hadoop or Swift or Ceph. Here I have some Ceph, I can deploy Swift on top, on the side. Or we also have charms for Cisco 1K, for NetApp, for all those guys. But they are not in the charm store because they are not open source product. But there is charms for those guys, and we can provide support for it.
Is there a mass cloud in the internet that I can log in, pay, and then run some...
real hardware using the mass interface? Not that I'm aware of. If you want to run that business, let's get in touch.
Okay.
No, that's real hardware you get to.
No, I mean,
we are in the business of doing the software and some services. This is more, if you know someone running data centers that will be interested by that, we love to talk about it.
Offering the bare metal is open and you can play this.
Yes, we know. We started this years ago. It's 4 years ago. So, but it's very generic. We work with any vendors and any hardware around.
Talking about OpenStack, openness, and everything. Do you
Yes.
have any kind of a unified declaration model that you use underneath to define everything, all the pieces and the relationships?
Not sure I really get what you're looking for.
We've been hearing about, for example, Tosca
Yes,
as an example of
very interesting.
Yeah.
We look at the Tosca standards, and IBM came to talk to us about Tosca, and I don't know when it will be together. We bring Juju to talk Tosca. So you will be able to you will be able to export your diagram made by the GUI into a Tosca format, and you will be able to do the contrary, integrate a Tosca format, and Juju will be able to deploy it for you.
And in your opinion, is it becoming a standard? Or is it just IBM?
It's not just IBM, it's a standard by Oasis. It has all the characteristics of a true standard. Then it depends if you want to define a standard by the most used thing or a standard by a committee.
Yeah.
So Tosca is definitely a standard by a committee, and it starts to be really used in many different products, even commercial ones. So it's a very interesting endeavor to go. Basically, the biggest change we had to ask Tosca to do is to define was to use YAML as a supported format, and a few little tweaks here and there. But the models were so similar that it was very easy to make Tosca and Juju talk and work together. The model, the data model, and the description is extremely similar. So it makes things, and here we go. We have an OpenStack deployed. Let me do a check on that. Someone check the time for me, or how much time do I have left? I'm already late. So let's just go to the dashboard to see it running. And I created a little script to set up the network and load some image. Nothing very complex or fancy, just normal OpenStack commands, neutron, glance, add things. Just to show you it's a real one. Here, if I go to the hypervisors, oops, there it. Okay, then I can show you the Horizon launching instance and stuff, but we run out of time. It might sometimes go faster. It really depends on the network speed. And for your info, I use my phone to a Wi-Fi connection, so in a venue. So you see how adventurous we can be. To deploy a full Icehouse, a complex one with Ceph. So you have probably, let's put that here, a little bit bigger. Just for you to see, we have Cinder, and that little guy allows you to configure in Juju several backend. So here I put Cinder to Ceph. I can add another backend. I can add NetApp. I can add something else. It's not one or the other. You can use a bit of both. The gateway, Glance is using Ceph here too, etc. And then we can integrate that, and Juju itself has an API, and we can integrate Juju with our tool called Landscape that will be able to give you a report of the full usage of your OpenStack cloud, and being able to see the trends and have a full dashboard integrated with it, allowing you to easily adapt and go for there. And here I also put Nagios. And if I want to monitor more services, the only thing I have to do is this. Build relationship with all the other services. Oh, doesn't work on that one. And here Juju will put the NRP agents on all the units that those service runs. And if I spin off a new unit of that one, it will connect to all the other guys plus the agents. And if I want to replace, I can do that. I can upgrade too, of course. You can just Juju upgrade your whole bundle and adapt to it.
And, I have a separate server, like all kind of servers. Server with a number of disks and a number of sockets. So, and I can connect all these servers
in mass, if you have a network, yes.
And then build on top of it all.
Anything OpenStack or something else, but yes, OpenStack is a good choice.
Okay, and from your experience,
But the hardware should be certified, right? Like you support certain
No,
hardware.
it will work on most of them. We guarantee only the ones that are certified. So,
okay, and from your experience, for running a real OpenStack, let's say, high availability cloud,
yes.
how many such servers I need, minimum?
For a full HA, really distributed with, say, around 30.
30. Okay, and this something smaller and not fully.
Then you can play a bit like I show. Non-HA, you can start with 6 to 10 good servers to have a full HA OpenStack, meaning every service is HA. It requires more units and more servers. You can find a line in between, but this OpenStack has been built to manage thousands, so it should be easy to find 20.
No, I'm looking for a minimal configuration.
So if you don't have such performance requirements, you can co-locate some services, put in containers, put some VMs. Some customers do that. So we can help you build and architect that for you. I probably have to stop now, right? I don't know if is the next speaker there already?
But it will be great if you will say like 2 sentences.
Yeah.
Concept state
So, to close.
Don't say.
For the opening that we.
Yeah. Okay.
Start from the beginning.
No, I will start again. Yeah, the panel will start soon, and after that, real life Icehouse installation on real hardware on site. We're going to go to the next session around orchestration. Bear in mind what you've seen during that sessions. That will be very interesting for the discussion we're going to have with those gentlemen coming now. Thank you.